So
This
somebody
conference
asked
will
me
now
if
be
it is not
recorded.
toxic. Somebody asked me if it is not toxic, how did it kill? Then I went back and studied a little more and found styrene liquid is a fire and explosion hazard, but styrene vapor is a toxic hazard. Then I learned styrene vapor has an IDLH of about 800 or 900 ppm, whereas the LEL is 9000 ppm. So what I learned is that we are all in a wrong impression in all hydrocarbon industry. It is a fire hazard that is number one. Actually, it is a toxic hazard, which is almost a 10% of the LEL.
Absolutely agree with you.
So it will kill before it burns.
Yes.
So I found out all hydrocarbons are Hindus. They burn the dead bodies.
Okay. All right.
Okay, that's all my contribution. I will remain silent now.
It will be pity, sir. I would rather see you intervening once in a while when you feel it appropriate.
Okay, no problem.
Anyway, we can discuss later, sir, because this styrene problem is very common right now. There are so many storage areas, and we had organized a webinar some 15 days ago on this subject. It was quite interesting participation, and we hope that we can again repeat on these operations.
Sure, we have a new gentleman, Umesh Khandalkar, who is now in charge of fire in place of Koti.
Oh.
He is from Jamnagar, Umesh Khandalkar.
Umesh Khandalkar, okay.
He is our center of competence in case of fire.
He's not the person who was at IIT Kanpur by any chance, no?
No. He is Umesh Khandalkar. He must be from National Fire College.
I see, all right. Because there is one Khandalkar who is also a fire.
No, he is the only one with us for Jamnagar for the last 20 years.
And combustion expert at IIT Kanpur. I thought it was the same person. So I think it is 12. Nirav, can we share?
Pardon?
Hello. Yes, sir.
Nirav, should we
yes, sir. Yes, it's almost 3:30, so we can start it now. It's started by Mr. Sharat Tripathi. Is managing director at Fluidyn and sitting at France. So please, Sharat sir, can you start with introduction? So we'll step by step go ahead.
Webcam, and I'm sure Swamiji will not be happy not to see my face. He is, he reads everything in eyes, you know. So if the eyes are not visible, Swamiji is not happy. Isn't it, Swamiji?
I would like to see your face, man. After all, you are the pointer and you are the person who started rolling the ball. So let me go ahead, please.
Let me see if you can see now. I'm Sharat Tripathi. I'm based in Paris right now. In fact, I would love to be in India, but as COVID was starting, I came back home, and so this is where I am right now. But for the last 50 years, I came out from IIT Kanpur in 64, 69 batch, fourth batch, and been here now for almost 50 years professionally, working in various areas. For last 2 years, I had been spending my time mostly in India, and for one reason. And why I'm talking about this is the genesis of this webinar series also. We have been operating in China for last 6-7 years, and we found that 3 years ago, Chinese put an ultimatum to us that we should do the development in China rather than working out of France or from India. And that was a kind of click, because I realized that it's a pity that in India we are not putting emphasis on the design. Design is important not only for equipment, but also from fire point of view, also designing the building, designing the equipment, designing the safety. Depending on things which are coming from US, from Norway, from France, etc., really has no meaning. Things are usually 10, 15 years behind the time. And that is, if we really want to at least equal Chinese, we have to adopt the same aptitude that self-dependence, independence should not be limited for the make in India only. It should be first designed in India, then only we can beat Chinese and everyone else. So this webinar series is devoted not to the software, not to the applications, but to the technology, to the professors, to the students. We would like to engage them into new developments, into new research. Unfortunately, it is not going on at all in India. Go to any IIT, you'll see that the numerical technology professors are practically absent. Everyone will talk of applications using the tools which are developed in US and elsewhere, but there is no motivation, no impetus, nothing is given by the industry. So this webinar series was started essentially to bring the industry, to bring the students, and to bring the faculty on board, that including Fluidyn. We will also, right now we are working with French universities and academic institutions. We are financing PhDs. We would like to do the same thing in India. So before everything else, our endeavor should be to support and tell students to come into this line, develop our own things for designing, for risk analysis, and for future technology. We cannot use the technology like FDS, like ANSYS, etc., which are developed 10, 15 years ago. In their own countries, they are using much more advanced tools than what is available commercially outside. So in India, we should also have our own tools, and that is the only way, that is the only guarantee that we can develop anything further. From this, at this point, I'll hand over the things to our eminent panel head, Shamiji. Shamiji is the prime interested party. He is the fire brigade advisor to the government of India and to all of us. And he is the one who can define what are the requirements. Shamiji, can I hand over to you, please?
Yeah, thank you, Dr. Sharad Tripathi ji. Thank you very much. Good evening, ladies and gentlemen. Let me thanks to Dr. Sharad Tripathi ji of Fluidyn for organizing this webinar to bridge the gap between the technologists, users, and the various applications. I'm thankful to him. He keeps on talking that how to increase the use of available technology for saving life and property. More or less, he is worried about the toll, which is going day by day. I mean, up, which is going up day by day. So he's more or less concerned with that, and he approached me that if you implement the technological part of it, it will definitely increase your saving rates. So thank you, Mr. Tripathi, and your team for organizing such a beautiful webinar for us. Rather, I must say, you have a lot of experience and the expert, professors and doctors in this particular session. I am not expert like you, but I, as a fireman, sometimes I keep on asking the question with the experts that whatever you are making should be implemented, should be available to the firefighters at the low cost, to the public at the low cost with the high impact. So as being a fireman, it's always my request to all of you that whatever you are making, whatever the high end or the different end of a solution you are putting out, it should be implemented in totality in the all fire brigades in the all over the world. So I accept the rich data provided by the various softwares in formulating the policies. I am one of the expert members of the National Building Code of India, a document which is a Bible for the Indian fire and safety professionals, including the industry. And I'll put on record that we have used the various data provided to us by the CBRI Roorkee, DRDO, and the other experts after doing applying their tools for arriving such a formula. And we implemented and mentioned all those rich formulas in our National Building Code of India. And because of that, I can assure, if anyone can implement the fire safety requirement of as stipulated in the National Building Code of India, he can ensure himself that he is living in the safe building. I can assure him that he will save up to 99%. 1% I am leaving for its proper implementation and maintenance. But this National Building Code of India is a wonderful document, and we have adopted this. Tripathi sir, this engineering simulation and the fire modeling like concepts are getting momentum in India. Now there is two types of a fire man in the country. One is a purely fire engineer, and one is a firefighter. And there is a little bit discussion, debate. There's a little bit discussion, and there is like a debate that why they should adapt, why they should the prescriptive recommendations. They think that if they will adopt the performance-based recommendation, it will save money, it will save resources. And we had a discussion, and in one of the international seminar, we asked the FM, UL, all our academicians and the firefighters to discuss on this issue. And to all of your surprise, we concluded that for the time being, the prescriptive document is more valuable than the performance-based document. The reason is very simple. Presently, we don't have such a rich institution who can, after formulating the technological based on the various tools, should train my firefighters. Number two, the firefighters are not of that high level, having the high level of academic engineering background. The regular firefighters are good in firefighting. They are good in rescue. They are good in emergency services. But to understand the mathematical tools, they need a specialized training so that they can apply. So my, as an advisor to the country and to this august distinguished participant, my request is that whatever technology you are developing should be easily available to the last person who can implement it in their area to save the lives and the property, right? To use this technology, and after recognizing the use of fire modeling and the fire simulation, I, with the help of Indraprasth University of Delhi, developed a one postgraduate diploma in fire auditing for the fire auditors. And in that 1-year course, we have put one complete unit on this CFD or the fire simulation, the fire modeling part of it. And we want that until and unless the qualified person understand this, he cannot implement the auditing work freely. So slowly we are trying to inculcate, we are trying to introduce this high-end engineering solutions to the all auditors, and once they qualified in this, they will definitely implement it. Presently, as per standards and codes, fire modeling, fire simulation is, and the CFD requirement is not the mandatory requirements in India. It may be elsewhere, but it is not in India, and probably India will take another 3 years to implement in a right perspective. We have introduced a different syllabus for the various courses, including the Bachelor of Engineers at National Fire Service College, Nagpur. Dr. Dhananjay, who is the fellow colleagues today, he will explain that what all we have implemented in National Fire Service College, Nagpur. Perhaps more than 100 fire engineers are waiting for to get the rich knowledge of your this fire simulation engineering. Perhaps you may join in your main streams to learn and rather develop the futuristic technology. In addition to the National Fire Service College, Nagpur, and this IP University work, I supported the Fire Safety Association of India in their fire indexing. Mr. Ashu Gupta, who is another my colleagues in this panel, he will today explain about the introduction of this safety index. And in this safety index, they have mentioned the importance of CFD. And through that also we are trying to introduce this rich experience and the knowledge and the technology for the public. Third very important example which I want to share, that after the Greenfield fire, you know, the few of the resident, they started asking the fire experts to provide them the solutions to certify that where they are living is a completely safe. And I mean, with the proud, I can say that few in India, they approached to the consultant, and this consultant, they did all the CFD work and they certified it whether their building is safe or not. So these three are the main, you know, the area which shows that the paradigm in India is shifting from the prescriptive to the performance based, but it will take some time. My last panelist is Dr. Claude, and he's an expert in his field. Probably he will talk more about the technology part of it, and he will also share his knowledge about what is being done in his country to help us to improve my own document. So with the rich panel, now I will hand over and thanks to Dr. Sharad for giving this opportunity to me. So Dr. Sharad, can you take over and then ask my another panelist to go ahead as per the programs to present on academic requirement for fire and explosion study?
Yes, of course, Dr. Dhananjay, you are very welcome, please. You are the guide and we are counting on you for future. Your students should be are our future, and primarily it is designed and driven, should be driven by faculty like you. Thank you, sir. Can you join in?
Thank you, Dr. Sharad Tripathi, and thank you, DK Sami sir, for giving me the opportunity to explain what we are doing at our National Fire Service College. Shortly, I am going to present my presentation. Just give me a second.
Dr. Dhananjay, if any issue, I can ask Ashu Gupta to take over.
Just a moment, it will be done shortly.
Okay.
Meanwhile, Ashu, are you ready?
Yes, sir, I'm ready on that.
Okay, please stand by. Yeah, fine.
We can see that.
Yeah.
So good afternoon, everyone. I welcome you all on this webinar on engineering simulation of fire and explosion. Today, I am going to talk about the modeling and simulation in engineering education. So the content for today's topic is, first I'll give you the introduction, what is modeling and how it is beneficial to the education academicians as well as for industry person. Then I'll talk about the engineering simulation at NFSC. Then what are similarities between the experiment and simulation?
Dr. Dhananjay, sorry for interruption. Can you zoom out your screen in presentation mode?
Differences between simulation, differences between experiment and simulation, advantages of engineering simulation, and the challenges which are present in accommodation. My main focus is, yes, Now it is okay.
Yeah.
It is okay.
Yeah. Please go ahead, Dr. Dhananjay.
So the modern engineering workplaces commonly use modeling and simulation practices. Basically, here I am talking about the industry. Industries most of the time they use computational tools for their analysis and design of the system. As a graduating engineer, NFSC mainly focus on to develop the techniques, skills of modern engineering to graduating by concentrating them on identifying the problem, explaining the problem, what the problem consists of, and how they can apply the tools which are available in front of them to solve those problems. So basically, our main focus is on three things: identify, explain, and apply. At NFSC, basically engineering simulation, we are having the subjects like numerical methods of fire engineering, then fire modeling, fire dynamics, structural fire safety, and fire risk analysis. These are the just main core subjects which we are teaching here. Apart from that, at NFSC, we have developed the computational labs having the 30 personal computers and along with the one workstation. Apart from that, NFSC has purchased some softwares also in which the students are given training. So those softwares are basically categorized into two parts. One is the general purpose finite element softwares which we are using here, and apart from that, we are also having some specific softwares which target on a particular type of problem or the training to enhance basic knowledge using simple models. What are the do's and don'ts of the simulation, how to validate the results, and at the last, when students are aware of all these techniques, then we train them how to simulate the complicated multi-physics models. Here multi-physics models means different type of problems can be, for example, acoustics blast, then how it is going to impact the structure. So all those type of problems comes under the multi-physics models. Then the question arises, what is the similarity between the experiment and the simulation? Whatever the results we are going to get from the mathematical simulation, same results can be we can also get the same results from the experiment. However, simulation we can do it in the computers, whereas experiment required lot of facilities. So earlier when the computers were not developed, so people rely on the experimental parts. Now as the personal computer developed, computing facilities enhanced, people slowly shifted to the simulation part, and from the past decades, people have developed lot of confidence on the simulation. So first point is both experiment and simulation share the same structure, means both of them are in the same line. In this, we can also control the environment. For doing any experiment, we have to control the environment. Certain experiments require strict environmental control so that the results will be error prone. So same thing can be done in the mathematical modeling. Experiment and simulations are bound to have some error. So proper error management technique is also similar between those two. And also we can develop some new, we can also find some new or potentially surprising theory by using the experiment and simulation. Then there are some differences between the experiment and simulation. Experiments can provide us the new empirical data to some extent, where computer simulation fails, because whatever the computer simulations we do, those computer simulations are backed by the experiments so that we can match those results. But if you want to find some new empirical data, in some cases computer simulation cannot help you in finding the empirical relationship. Some experiments operate directly on the target system. Target system, for example, if you are doing the testing on the structural member, our target is to identify the fire resistance. So some experiments can directly act on the target system. Some computer models never do so. Experiments can be used for testing the fundamental hypothesis whereas computer simulations never do. Advantages of engineering simulation: it provides feedback in while designing and analyzing the real world system. So before going for actual manufacturing of the particular whatever structure or any system, we can do the analysis and design, and if we are confident that this is going to work, we can carry on with the design. So this give us this is also a cost effective measure, which is the main advantage of using the engineering simulation. It also permits designer to solve a problem at different level of abstraction. In this, we can change the input data. We can see how the results are going to change. So basically, we call it as the sensitivity study. Then simulation can also be used as an effective mean for teaching or demonstrating the concept to the students. The challenges in engineering simulation: it requires high expertise, because it's just like a two-blade sword. It is a boon to us also simultaneously. If it is used in the wrong way, so it is going to give you a lot of problem, because the results will be meaningless, and ultimately at the end you will achieve a failure. So expertise is required to handle this engineering simulation. Apart from that, high computing facilities are required, because if you want to analyze any dynamic system, it can take weeks also. So without high configuration computers, it is really difficult to get the solution. But we are fortunate that nowadays some companies are there who can share their servers at a small cost. So that is also an option which is which is available to us. And sometimes simulation might not be realistic or reliable. So while using this engineering simulation, we have to be very cautious and always have a question mark in our results, so that wrong results or meaningless results can be effectively filtered out, and at the end we'll get a good and meaningful results, so that our end product or end output is error free. Thank you.
Thank you, Dr. Singh. It was very, very kind of you, and a very good perception of how and where the simulation and experimental engineering should go. Can I invite Mr. Ashu Gupta now to?
Sure. So I think, Nirav, I
Yes.
would request you to please give me the presenter assist so I can present my screen. Thank you. I can share now.
Yes,
Great.
sure.
All right. So hope all are able to see my screen now, right? Yeah, Nirav, can
Yes,
you
it
just
is
confirm
visible.
me?
Yes, yes.
Okay,
Yes, it is
perfect.
visible.
Great. So hi, good evening, everyone. First of all, I want to thanks to the organizer and Mr. Sami, because he's our mentor in FSAI. I'm representing, my name is Ashu Gupta, and I am a building professional. I work in the building, so of course I want to cover that part also, which is very, very important in our daily life. I am a master trainer. I have done so. I do a lot of trainings program for the different sector. I'm a vice chairman for the Fire Suraksha Index, which is a very new concept in India, and I'm going to tell you about that, what actually it is. So, which is the Fire Suraksha Index for the buildings, which is part of. I'm an active member in Fire and Security Association of India. So I'll tell you to brief about that. What is FSAI? FSAI is a non-profit organization established in 2002, and we are around more than 20 chapters in all over India, more than 10,000 members who work towards who works with the government, with the NGOs, to aware about what actually fire and security systems are available, what technologies are available. We work in those direction, and we are all volunteers working towards and all over India in this direction. There's a this organizations doing in all over part of India. So this organizations comes last year with a concept, because why this concept brought up? There are so many green building systems going on in all over the world, and we say that this is my building is 5-star green building, environment friendly building. But is that building safe or secured? Is that building, the security or the safety is there? How can the building, any kind of building, become a 5-star or platinum if the building is not safe or secure? So we and of course we have several documents in India which we follow to make our building safe and secure. But this FSAI, which is the Suraksha Index, it is not kind of any rating; it is an indexing. you can, if we follow this design concept, you have to follow what NBC is saying, which is the National Building Code says. And over and above that, if we follow this more technical guideline, then our building will be more secure and safe. So I'll tell you that what exactly this index. So this index prepared last year. Already we have some projects which has been assessed by this indexing, and some of the hospitals in that, some of the hotels in that, and we the FSAI team is working to make this indexing in a big way. So this having a one requirement which is in section 4. Now I'm talking about the simulation, because in India, which because we do a lot of designing of the buildings in last 12 years of my experience, there is no concept of the performance modeling. There's a prescriptive approach every time. When we follow the National Building Code Part 4, they always says that this is a prescriptive approach which we need to follow in the building design. And we are seeing in the last several years, every year building the human safety in the building, and design of the building in last 10 years or 20 years has been changed. Now we have so many high-rise building, so many human occupancy, like in airports or in convention center, we have several people inside the building, and we are using the same prescriptive approach to utilize that. How can we convert to the performance approach? So we tried our best in this index to, if some projects goes beyond the NBC and they want to do the simulation for the smoke extraction, for evacuation modeling, for visibility analysis, that project will get some kind of points, or indexing will be more high in that. So this is we brought this concept, and we have seen several projects in India in the I would say not several, very few projects, if we say in that they are opting this concept. They are going, they do the fire evacuation modeling, they do the fire smoke extraction analysis during the design concept. And if we use those concepts, then definitely adds up a lot of value. So I'll give you some of the projects in India which I was involved in, which we did. So evacuation is very, very important. When we say the performance based analysis, we have to calculate these A set and the R set time, which is called the available safe egress time and the required safe egress time. So what does that mean? This graph will definitely tell you how the fire ignites, then how we detect, when the alarm raise, and what is the recognition, response time, and the travel time. Then some of the margin of safety. Entire time is called the available safe escape time, which is called A set. And R set, of course, before the margin of safety, whatever the time to evacuate of the building or escape the building, it is called the R set, the required safe escape time. So I have seen these kind of studies. The people have been proved because they have applied the performance approach. They feel that if you can see the visibility and the temperature, of course, the visibility is more important. When you're 10 meter, if it is dropping less than the 10 meter, it is not safe. We need to evacuate by that time. So this safe egress time, some of the analysis we have done in some of the projects which we found. The time which is coming is 540. So I'll tell you, this is the same project in the level 1 building, level 2 building, and we calculated that level 1, the 780 seconds, the building, the level 1 should be should be escaped. This is the time we calculated because of the help of simulation. There is nothing in the prescriptive approach which we can directly say this much is the time required to evacuate. Generally we say that some 10 minutes or 12 minutes, but this is the exact number come with the help of simulation approach, with the help of performance approach, because building different kind of materials comes up, different kind of building materials comes up, how the smoke will flow, this can be happen in this day. Similarly, for the evacuation analysis also, this is very, very important, because now we have several airports coming in our India, in our country, several hospitals, and the building now, the high-rise buildings are coming. Earlier we were making a 10 floor, 12 floor. Now we are talking about 100 floors building, or the more than 100 floor building, how the people will evacuate if the fire happens. And this kind of analysis, if we do during the design of the project, it will adds up a lot of value which we have calculated. So this is actually the prescriptive. I just want to explain the prescriptive and the performance approach. In the prescriptive, we have a National Building Code 2016 version, which is the latest one, And after performance, whatever we do, we follow the NFPA 101 concept. They have a requirement of a total occupancy, and most of the time our fire officer always say that we need to meet these numbers. This is the maximum occupancy we can reach out. But sometimes the client want that my occupancy should be high. In that case, how can I prove that? And this proof can be happen because of the fire, due to the fire evacuation modeling can do that. And we have seen in this one of the project in which this is the India project, in which they want the, of course, as per the requirement of NBC, they can involve only 6,147 person as per the requirement, and evacuation time. So we calculate the both prescriptive and performance method, and we calculate the evacuation time in that. So total occupancy, total occupant was 6,147 in the building. This is the video I'm not running right now, but we calculated if we go with the prescriptive method with the NBC 2016, the 780 second is the maximum time for the which is available safe egress time, but the required time was 340 second, 363, 375 for the 6,000 people. And the client wants, if we want to increase these number with the performance approach, if we go with that number, this can be 8,000 people. We did with the 8,000 people can do. So 8,000 people was involved, like it as 8,000 people. We did the same analysis. The maximum time was the same, but the RSET was 466, and it was coming in between of the the available time. And we proved to the fire officer that this is happening, sir. We can, if with the 8,000 people also, we have a very enough time to evacuate those things. By the prescriptive, there is no way to prove that, but the performance approach, there is a way to prove that, and people are doing. But still in India, there is no provision for the performance approach, because I'm a building expert. The similarly work I do in the energy sector also. In the 10 years back, energy simulation was not a concept in India. Always people were talking about this is the material which I need to procure, but the concept has been changed. Now the person understands the value of simulation during the design process. We saved a lot of money, but here is the cost is not a money, is the cost of human, because the human, if we save one life, then it will give a lot of value in the simulation. So my presentation was basic of the cover, but FSAI Fire and Security Association is doing a lot of efforts to develop this, and we want the people in this area, please come forward as a volunteer involved in that, because we are trying to develop something for the government that if this follows, definitely it will be part of the building regulation. So thank you so much for the time. Thank you, everyone.
Thank you, Mr. Gupta. It is very kind of you, because finally we know where we stand, what is the status of art existing in present situation in India. And at this point, I would like to present Dr. Claude Suprayan. I'm sitting here in Paris, and Dr. Suprayan had a very checkered academic history, so I have invited him to talk on with his academic background. He taught in Cambridge, he taught in Spray in Italy, then he taught in France, and he had been our consultant for last 15-20 years almost. He will delve into the technology and tell you where we stand. There are many things which are not published. It takes easily 5 to 10 years before any technology comes into the market. So it is very important to have an eye on what is going on, and hopefully our professors from CBRI, from IITs will help us develop a technological base where the developments and various tools which are developed for Indian market will at least go into the developing countries market, instead of just using the American or other tools. Can I ask Dr. Claude to come on? Claude?
Yes. Thank you, Sharad, for giving this introduction to myself and to the work. I don't know if you can see my screen now.
Yes, it is visible. If you can maximize it in presentation mode, it will be good.
All right. Okay, good. Thanks.
Screen.
So in this presentations, I've been asked to give an overview of both regulation aspects, objectives that handle the fire and risk assessment, and how and when consequence modeling can be produced in order to help in the assessment. So I'll give you an overview of what is really done and requested by local authorities here in France and in Europe. And also, I will try to explain which are the most progressive way to simulate these and to model these fires with design objectives first, which is hopefully simple enough to be applied quickly for industrial sites and for assessment of mitigations and protection devices. And the other one where we go more in depth in transient modeling of fires, looking for loads, looking for stress analysis, collapse of structures, and those kind of things. So a few words about Fluidyn. Fluidyn, basically, it's a consortium of technical centers in France, in India, subsidiaries in US, UK, and agents in China, in Japan, in Korea. And the activity is twofold, in fact. Scientific software development, this is where, building on Sharad comments, we would like in India to develop the tools from the Indian centers and to diffuse those tools for India to be fully autonomous in the development of those tools and their diffusion and application by engineering schools and by industries. And the other activity is about consultancy jobs, and this is where a large part of expertise is built, always and often, or at least very often, with respect to regulations requirements for industries. So I have a few slides of introductions just to overview and complement what has been expressed in terms of fire activities and fire safety applied to public buildings and malls and so on. I will focus in this presentation on industries, which is slightly different, even though most of the scenarios are looking similar. Objective for smoke evacuation, temperature load are similar. The responses are not exactly the same. So in this slide, you can see basically what are the phenomena and effects at play and what we are looking for when producing the risk assessment for fires. Most fires, or all fires, are combustion of gases, gas mixture. Indeed, even solid fire and liquid fires are starting with decomposition, fusion, evaporation, pyrolysis, which is producing the gases, and flames is basically gas phase combustion systems. What we'll be looking on more specifically, it's about thermal fluxes on the environment, looking for damages, losses on structures and assets, injury to people, both on-site, off-site, when talking about industries. And the other issues, of course, are toxic byproducts from the combustions, loss of visibility, and ultimately pollution of mainly water and soils via the wastewater and surface body waters. So we should say that there are many different typologies of fires: outdoor fires, vessels, full fires, jet fires. Usually those fires are well ventilated, and indoor fires for within the building, again involving liquid, solid mixture, and storage. So if we look at short range, when making modeling and assessing the power, which is the very first ingredient for the assessment of the risk, most of the power is from heat transfer, radiative and convection, from burned gases and soot. Everything is at high temperature and including burning char, which can be inside the smoke. Radiation at short range means few meters away from the sources, And this is important for propagation, of course, of the fire. And one usual issue about fire is assessing which part is going to convection, so might reach long-range distances, and which part is going to radiation. So the sketch you can see here is basically the typical shape and zones in the fires, and the way the energy from the fires are going outside from the source terms and the fire region. You also have a few examples of order of magnitude of temperature which are reached at the fire short-range domain. Now, looking for the regulations and the several aspects with respect to the risk assessment. Of course, evacuation is something for people, specifically for places where general public is operating and located. But in industries and in the design of the buildings and infrastructure, resistance to fire is something which is important also. And from the regulation point of view, there are classifications of structures and materials with the level of resistance. In France and Europe, 3 letters are characterizing the resistance to fire: the R, E, and I for resistance, air tightness, and insulations. And the second item is about reaction to fire. It comes to see whether some materials have the potential to feed the fire at degradation or decomposition, and to enhance the development and propagation of the fire. So it can be droplets, can be debris, and the European classification, you can see examples given here, also includes indices for smoke opacity, and this potential production of droplets and debris from the decomposition of the materials. So you see example of classification: SF, PF, CF for the materials. The most demanding one being firewalls and structures and material that stops the propagation, stops the heat transfer, and so on, which you can see on the right-hand side of the slide. When talking about regulation, the protection of people and structures are all coming to thermal effects, both for continuous long duration exposure, which is different from explosion, where you have short duration pressure blast and pressure effects on people and assets and structure. For the fires, basically you also have order of magnitude of fluxes and typical effects that can be produced by those fluxes. The yellow one are the thresholds for effects in kilowatt per square meters. For irreversible effect, which is 3 kilowatt per square meters. It is for fires for duration larger than 1 minute to 2 minutes. The second one is 5 for the first lethal effect. Again, same duration for fires. 8 for 8 kilowatt per square meters for significant lethal effects. And you also have ideas about domino effects and propagations at 8 kilowatt per square meters. You have a spontaneous combustion of woods and paints, and in some situation, propagation to other hazardous reservoir materials which are on the assets. So based on those regulations, I should emphasize that in France, there are 2 corpus and 2 bodies of our regulations. One which is under the control and changing and improvement by the French Ministries of Environment, which is handling both the industries and energy. And the regulations are based on the classification of activities. ICP means classified installations, Seveso, large industrial site with major hazardous risk, and nuclear. And you can have a few examples of classification. 1510 is for warehouses. The other one is for flammable reservoir and flammable liquids. So it amounts to the analysis of oil and gas depots and farms. The other one is for waste and recycling, where you have accumulations and storage, including processes of waste, where paper, paperboard, wood, electrical equipment can be located. So for those kind of regulations for industries, they imposes strict application for design, inspection, of course, risk analysis, for prevention, protection, and in the risk analysis and QRA, quantitative risk assessment, looking for consequence modeling for fire, for propagation, for assets and structural collapse, for operators' safety and evacuations, and ultimately for environmental impact, pollution, smoke, and so on. And in the risk assessments, there is in this regulatory requirements which apply to the industries. You also have to take into account access and resources to firefighters on site. So the other body is about Ministry of Internal Affairs. It's handling mainly public buildings, infrastructure welcoming general public, malls, transportation infrastructure, museums, and so on, with very specific requirements for sorry, this is English, this is French, immeubles de grande hauteur, which are high-rise buildings, where the requirements are much more strict for structural analysis, for evacuations, ventilation, massive smoke extraction. And in that case, the regulation requirement is about design, inspection, risk analysis for complexity depending on the occupational rates for the number of people to be evacuated in short durations. Prevention, looking for removing any high calorific capacity material that can produce high energy fires. Design for the volumes, for the access and evacuation doors, for dimensions, path, and qualified performance, meaning that for various fire scenarios, the performance of the systems, both for smoke evacuation and for people evacuation, has to be qualified. Again, in these requirements for those kind of infrastructures and public buildings, there is a need for access and resources for firefighters. So at Fluidyn, basically, we try to develop approaches and specific softwares in order to propose a solution that have increasing complexities. Some of them are for dimensioning designs, other are for more complex situations where you want to look at transient for fire propagations, evacuation issues. So Vanfire is one of the solutions which is developed in India by our Bangalore team for assessing the transiency cases. The very small example you have on the left-hand side is an analysis for parking lot with a car fire, which is a small red zone, where we look both in temperature, in visibility for the smoke, and on radiation on the structural elements supporting this underground park lot, the pillars and so on. On the other hand, for quick and fast analysis, conservative way to do it, we also developed Fluidyn Panfire, which is handling steady fires and looking specifically for fire radiation and loads, again, on the firewalls, on the nearby storages, and looking for outdoors impact. So you can see an example of application on the right-hand side with building walls, fire-resistant walls, where you have storage inside the buildings, and you're looking specifically on how the radiations may come out from the roof or from the openings and may impact the environment and the nearby buildings and assets. So this quick design engineering solution is very helpful to assess the layout of the plant and to see whether various mitigation might be efficient to reduce the impact. So the first, this application, PanFire, is using solid flame models, which is basically relying on empirical correlation for the flame height for the fire. So two important parameters, you have the flame geometry and flame emissive power, which is a very robust way to describe things like pool fires, jet fires, and so on. And basically, when looking at more complex fire cases, for example, for storage, it also takes into account the way the storage is assembled. You see on the sketch here, example of combustible material assemblies, and the combustion rates, which is one of the first parameters which is important for the solid flame models, will depend also on the assembly of those storage. The second parameters, of course, is the heat of combustion and the radiation at the flame. So the flame emissive power in solid flame models is relying basically on estimates from experimental data for various burning materials. So based on the surface of the heat release rate, we can estimate for the solid flame models. In this specific tool, Fluidyn PanFire, we can estimate the surface heat radiation part of the combustion power. So you have example here of typical heat release rate for various burning materials. Can you
This
see the
conference will
presentation?
now be recorded.
Yeah, Claude, continue.
Okay. All right. So
This conference will now be recorded.
this is the way
Please, do not record because there are interruptions. We'll send you the slides you want later. Claude, you have you should close it in next 10 minutes, not more.
Yeah, that's okay. So this is the first aspect of
This conference will now be recorded.
BE boys, how they are encouraging the BE boys to convert all their theory into practical by developing the part
This
of it.
conference will now be recorded.
In addition,
This conference will now be recorded.
Are defined in different classes. There is also compressed gases being stored, and inside the buildings we are using these compressed gases, the liquefied gases, and a lot of hazardous materials. So the way we go about it is first laying out the safety distances so that we are segregating the flame proof and non-flame proof. And while the plants are being built, the process is designed in such a way that we identify where are the hazardous operations, and certain instrumentation is inbuilt so that it takes care of this. But still, we have not had any experiences of any explosions, except one where there was a dust explosion, but we had designed it in such a way that in case of that dust explosion, it should be vented outside, and it worked that way. And then sometimes we come across experiences where we have to design pressure vessels where hydrogenation is taking place, and these hydrogenators, if they are not, if the operators make any mistake, you can have an explosion of a pressure vessel inside a building. So what we do is, as a standard practice, is develop the location of the pressure vessel in such a way that the explosion can go upward and outward and not bring down the building. So these are the sort of engineering methods that we follow. It's not written anywhere in any book, but it's come out of 40 years of experience of building these plants. So what I thought was, if there is a simulation model, Dr. Claude can advise us, where sometimes we have an accident called as a BLEVE. A BLEVE is a boiling liquid expanding vapor explosion, which you can't imagine the consequences, and it can bring down the whole industry. Is there any sort of simulation models which can preempt so that we can avoid any catastrophe. And it's just for the additional safety is what we are talking about. Currently, we follow all the norms of ensuring that we use flame-proof fittings in these areas where there are explosive gas mixtures being handled or solvent vapors are there. So we use extractions to take out the vapors from that location and send it out to safe areas. So everything is in place, but sometimes you can also have a human error. So in case of a human error, it's always advisable to be extra safe in the design. And we don't have time to build these plants. We are given maximum 8 months or 10 months to do the whole engineering of a plant, to build a plant. So imagining everything on a drawing board becomes difficult, and there are teams of people working. So if we have some simulation models, probably it would be advantageous to the engineers operating.
Claude, can you answer?
Yeah, I can answer this. In the present webinar, we've been focusing on fires, but we in Fluidyn are also operating software for explosion. So, in fact, explosion, as you mentioned very clearly, may have many origins. You have UVC, which is unconfined vapor cloud explosion. It's basically turbulent combustions with acceleration of flame, which is producing pressure built up from the cloud, and that then has to be designed for blast-resistant walls and so on. We can model this. We have dedicated software for this, which is Vantex. It's look like Vanfire, but is dedicated to explosion, which is of course occurring on much shorter periods, and with specific combustion modeling coupling with turbulence, deflagration situations. The second kind of explosion, it's what you mentioned also. It's pneumatic explosion. So when a vessel is an internal explosion inside the vessels with rupture pressure of the envelope that gives you a instantaneous release of massive energy due to gas expansion after the opening of the envelope. We call this pneumatic explosion. We also have the same kind of application and tools in order to model how the pressure builds up, propagates in complex environments, bounce in and out on the walls through the openings, and then escape. So we can estimate effects and analyze the deformation and stress which is produced by this pressure build-up and transiency, which is producing impulses on the surfaces. So based on the stress analysis, the same kind of stress analysis, but on shorter period that we produce for fire, we can also do it for pressure. The third one, which is the Blavy. Blavy, it's something quite different because the loss of containment of liquefied gas, which is Blavy means boiling liquid expanding vapor explosions, means that there is first an opening of the liquefied reservoir, liquefied gas reservoir, can be LPG, propylene, and those kind of products. There is a formation of gas and aerosol clouds up in the air for reservoir being outdoors. And then you have two effects, which is a fireball, which produce short, less than 10 seconds or several tenths of seconds duration, very big fireball, very energetic one in terms of surface power. And the second effect is looks like a flash fire. So pressure effects also is coming out from this. We do have the tools for this. So it can be applied either at the design period, where you know where the reservoir will be, you know what kind of scenario can happen on those reservoirs and those products, and you assess the distance at risk and the effects on the structure, and you play with this to design firewalls, to design blast walls, and those kind of things, or to also simulate how mitigation, for example, for UVCA, for expanding, unconfined vapor cloud explosion, you can also mitigate or prevent large emission of those clouds, looking for insulation of the piping systems, or looking for simple mitigation systems that can mix up very quickly the gases and so on. So we have real-time tools to assess the leak and to shut down the systems of the gas emission before the fire, either jet fire or explosion, can occur. And we can also analyze the effects of the explosion on the structures. So those tools do exist. They are applied in India from the team that has been developing those tools in Bangalore. Of course, in France, we use the same tools because from Fluidyn France and from Fluidyn Bangalore, we're sharing the knowledge and the technologies, and we apply it. So we can send you later on, if you want, a few slides and example of explosion cases, real cases that we did produce for oil and gas industries, but not only for heavy or important plants. It's handling also for boilers in hospitals, for many different, much smaller systems, including biogas production plants and so on. So those tools are really useful for the design and also for looking for mitigations if nothing else can be produced to reduce the inventory, the amount of material that can be released outside the reservoirs.
Thank you, Claude.
Thank you,
I
Dr.
think
Thank you, Dr. Claude. Sharad, let me add more thing to it. Thank you, Dr. Claude. Thanks for asking a very good question. You are aware that a lot of all India safety directed standards are there. PESO regulations are also there. But if you still feel, I mean, after working for 40 years and with your 40 years of rich experience, if you feel that there is a few more things to add on those standards, I request you to please write to the OISD and copy to the fire advisor, and I will take it up. I am a member of those committee headed, the top committee. So I will try to put this point and ensure you that whatever you want will be there in these standards and the codes of OISD. Thank you, sir. Now you can continue.
Thank you very much.
Shamiji, there is another question from Larsen and Toubro, Mr. Bashram Govindam, which is in the similar nature of the deflagration. Mr. Govindam, are you there?
Yes, sir. So can I ask my question?
Yes, please go ahead.
Yeah. So we were in a project where we had to evaluate what would be the effect of deflagration of a low hydrocarbon in air, and whether we should design our equipment for such a high pressure which comes after the explosion. We built an 1D model, but my question is regarding whether the 3D simulation models that has been done using very realistic simulations like CFD, whatever that you have shown, very detailed model. How does it differ from the usual 1D graph which is obtained from literature, and how does it compare with that? Is there any substantial difference in the pressure which we get, because our values are very closely correlating with NFPA values? So I'm just asking the question how different that could be. And my second question regarding the same thing is, would it be possible to design a very complex geometry in the software? I think it should be, but deflagration, would it be possible for a particular composition to have such a small transient variation, or would it be possible in Fluidyn? So those are my two questions.
Okay, I can answer the questions about the comparisons. 1D or 2D models are usually applying TNT equivalent curves based on initial energy which is available, which whatever the dimension of the vessels, the dimension of the cloud, or the property of the explosive material, it gives a vacuum as a function of distance, how the pressure is decreasing. And of course, those 1D or 2D models are very good first screening tools, but they are not using at all the exact design of the plant. So it is flat terrain without obstacles, without bouncing of the pressure and so on. And therefore, it is very quite difficult to assess which one to compare, in fact. But of course, the better you describe the site, the better you describe the process of the explosion itself, either by solving the combustion models, turbulence, combustion model for the deflagration of a gas, or the exact geometry of the reservoir before for pneumatic explosion, for example. It will always be better and much better description of the way the pressure is propagating away and bouncing and being reflected, and how the mitigation can operate and what are the performance of the mitigation systems. So somehow 1D or 2D models which are using abacus or analytical formulations are very useful for very first screening. But if you look at the descent at risk for even a very small reservoir, you'll end up with a very long distance, which is quite annoying in terms of implementation of the layout of the plant, and also may refer to far too conservative distance regulations to build nearby buildings, nearby industries, and so on. The example, I don't know if you can see the images on site. This is animations from an explosion from a boiling chamber on a hospital with nearby building with people living there. The explosion is starting inside the building and goes outside through the opening. So this is methane fueled systems, and the design helps to tell what are the surface for the vent holes. Are they good enough? In case of the geometry is not allowing for analytical empirical formulation to be employed. And also it produces the distance at risk, exact distance at risk outside.
I would also like to point out that very often most of the designs are done keeping deflagration in mind, subsonic explosion. But when the explosion is confined, it may turn into detonation, and which is much more deadly. Things like Buzzfield also happened because of the accumulation of the droplets, aerosol in the air. So subsonic explosion, which is making some estimations like 120 millibars is the maximum pressure, etc., is really not valid. In most cases, the tools which were using that kind of number in real life explosions, the pressures reached were much higher. Can I move on? There is another question from Mr. Amit Baran Ghosh from Reliance.
Thank you so much. Point is noted. Thank you so much.
Sir, we can come back to you, Mr. Govindam, again whenever you wish.
Sure.
Mr. Ghosh from Reliance Industries. Are you there, sir?
Yeah, good afternoon, sirs.
Please go ahead.
It was a nice discussion, and we came to know so many things. Mainly, it was a discussion with the design parameters of and the design basis what is to be inducted during the design stage itself in the building structures. My question was, we are in the petrochemical business, so this simulation or early detection with respect to some release sources, are you working on that? That was my question.
I think I'll take that question partially before handing it over to my colleagues. We have started working on early detection for terrorist attacks in early 2000. For almost 10-15 years, it was under the wraps because of its sensitive nature. Those things were not allowed, you see. And that is where the designing and in-house in the country development is very important. Those things could have been available. Those questions, Mr. Ghosh, your question, you would have been already using these tools some 15 years ago if these things were being developed in our IITs. Of course, I think at that point I'll let Claude or Arun or Amita answer. Can you please answer someone on the real time?
Yeah, I can answer these questions. Indeed, detection of leaks, gaseous detection of liquid, gaseous leaks or liquid leaks are precursors of massive accidents when you handle flammable projects. So the better and the earlier you detect the leaks, the better it is, because you can then shut down the systems which are feeding these leaky part of the process. Usually, detection systems are distributed around process or units or areas based on quasi-random or not really random positions. And we developed specific real-time systems that help first to deploy the detection systems based on the limit concentration measurements from the sensors, the time delay tolerable. Of course, it has to be as low as possible, but the time delay between the beginning of the leak and the detection at the sensors. So for the optimal deployment, we developed technology based on CFD calculations to assess the optimal deployment with limited number of detectors. And then when the leak is occurring, the system is locating the leak, which is not so easy to do when you have non-massive leaks, but sneaky gas emissions from pumps, from garniture, from corrosion holes, and those kind of quasi-undetectable leaks. So the systems will locate the leaks, get the leak rates, and do real-time dispersion of the leaks. So the volume of gas within the flammability limits will be assessed. And of course, for fast detection and emergency, the operators can operate on the piping system. So those systems are within what we call Fluidyn RT for real time. It's a twofold kind of applications. One which helps to deploy the detection systems based on the inventory and based on CFD calculations for the local metrology of the site. And this is an offline part, and the online part is collecting the data from the detection systems, concentration data, and then producing real-time maps of sources. So of course, when you have no leaks, there is no need for any action. But as soon as those maps are pointing some kind of leaks locations, there is a room for actions, and this avoids the accumulation of flammable material on the plant, at the process, or outdoors, outside the limit of properties.
Shamiji, I'll hand over to you, because the questions which were asked in advance, we have finished. Maybe there are quite a few eminent participants.
Yeah, thank you, Dr. Saab. But I think as per our specified time, it's only 2 minutes left out. I just want to know whether we can continue after 5 o'clock also.
From our side, we are available.
Okay.
Yes. We can continue.
Let me, in fact, I came to know that number of eminent persons are sitting with us as our participants, like Dr. Subir Singh. He is representing CBRI, and he is in charge of a fire section, and he is a group leader of a fire engineering group. And Mr. Ajay Raj Dwivedi is a professor and expert in the separation modeling. He is representing IIT Gandhinagar. Then Professor Sebastian is with us from France. Dr. Chandan Ghosh, wow, he is a professor who introduced me to Dr. Sharad. Thank you, Dr. Chandan, for all your good work. And I think since then we are progressing ahead. And you are in fact, the person who started rolling ball in India, and I tried to help you out. So thank you for joining with us. Then Mr. Atul Srivastava, he is the Vice President from Reliance Industry. Thank you, Mr. Atul, for joining. Mr. Kripanand Pandey, he's a fire discipline lead, L&T Technology Services. Mr. Yogeshwara, I think he's from Reliance Industry, I know him. And Dr. Surya also, I know him. He just, I think, spoke to Dr. Sharad. And Mr. Dharmesh Koshekar, he's a fire safety inspector of HPCL. I know him also. Mr. Jairam Nayak, he's the director of Andhra Pradesh Fire Services. Thank you, Mr. Jairam, for attending this webinar. And Mr. Abhishek Shinde is a senior manager in Indian Register of Shipping, and Mr. Nimesh Kakkar. So lot many people are attending. Sorry to mention, but Mr. Dr. Dhananjay told me that more than 100 Bachelor of Engineers from the National Fire Service College Nagpur, they are also attending through this, and few of them just want a rich PPT. so that they can understand and they can ask the questions with Dr. Dhananjay, the left out questions. Dr. Dhananjay told all the participants it's better to listen, because if you start asking this 1.5 hours, it's very short time. So you know, they are keeping a lot of questions and probably they will ask. So I request Dr. Sharad to please share this rich PPT to Dr. Dhananjay and be available to him so that he can give answers to students and also help, you know, this student to develop the theory based models for showcasing at National Fire Service College, Nagpur, which will help them understand the technology in a clear and the better way. I don't have much question other than the only one. This is a challenge to all the technocrats who are attending this session, that how and when you will give me the pocket-friendly version of your technology, so that I, as a fire advisor, ask my all firefighters to put inside of their computer and do the rest of the works to before issuing the NOC. So my question, since Sarad, you are there, I know you, and I don't know much more, guys. So I just want to know when we will provide us the pocket-friendly version of your rich technology, so that each of my firemen can introduce in his own computer without depending much on the cost part of it. I mean, a bigger server, or say the continual upgradation of a software or something like that. Sharad, over to you, please. Can you answer me?
Swamiji, thank you very much, especially for attending and encouraging words. In fact, you have taken the words out of my mouth. You see, after 50 years of life here, all that I am looking for is whatever is being developed in Europe should be developed in India. Good. It should be at Indian cost. It should be done by Indian engineers who can earn a good living without having to go to US and elsewhere else. If we start developing things in India, I'm sure, like general IT industry, which was based on low cost labor, should be based on high cost, high technology base, and we can export the same things to China and elsewhere. Our technology is being used by Chinese. Chinese are pressurizing us to do development there. We are not getting encouragement in India. Your question about a pocket size limited to the money available in Indian pockets can be developed only if the Indian industry rises up to it, encourages the developments in Indian institutions, encourages the development in IITs, and stops looking for technology which is 10, 15 years old coming from the Western world. So I would rather thank every one of you. It is very, very kind of you. I'm sure this kind of thing will go down to our young generation, and hopefully they will come forward and probably support our endeavor in future. I think, I mean, we'll work on it. We are working on it. And cost is not the answer. The answer is in the technology, sir. We will do everything for that.
Thank you, Dr. Dhananjay. Please take this as a challenge and try to encourage your boys to do something for us and use the available technology and come out whatever is required for the country. So the other thing I would like to know from these eminent participants, that since I have introduced this performance-based fire design in one of the course being run by the LP University, so I want a number of you volunteers who can teach this particular section of syllabus with available experience. So they can forward their name to me through email, and probably, Mr. Sharad, I will take some help of your team, and through webinar or through the distance education method, I can introduce your eminent speakers to my these participants of the IP universities. So hello.
We are always available, sir, whenever you want.
Thank you. So these 2-3 things were in my mind. I don't know whether any one of my panelists would like to ask any question. Dhananjay, do you have any question? Dr. Dhananjay?
No, sir.
Okay. Okay. Mr. Ashu, do you have any question to be asked with this? Mr. Ashu, are you there? Okay,
No, he
okay.
is not there actually. He left.
Okay, fine, fine. And Dr. Claude, do you have any questions to be asked from this side of reason? Do you have any question or any question?
No, no question. Just ask people to send question afterwards through the website or through the emails if they have one more detail on the presentation.
Okay. Anyway, I would like to thank one and all for giving their valuable time and sharing their rich knowledge. Some of the questions will definitely help us in improving my code and standards like what Mr. Jeffrey asked from the Mumbai. This will help me improve my own OSD standards. And of course, with the available technology supported by Mr. Sharath will help us in improving. Dr. Sharath, with these words, I will hand over mic to you. From my side is over. I would like to have more and more questions to improve my condition in my country. Thank you.
Besides everyone else, I would like to thank Shamiji. Shamiji has been always supportive, and I'm sure the technology will go much further out. And probably in 6 months or 1 year time, we'll have more faculty coming on board and telling us what they're doing about. Thank you, sir. Thank you, everyone. Thank you for joining. And please attend webinars whenever we do. They're essentially for development technology and not really commercial. Thank you again. Thank you, everyone.
Chandan Ghosh from IIT Jammu.
Please go. Yes, sir.
Hello.
बोलिए बोलिए.
Chandan from Delhi.
बोलिए Chandan. Hello Chandan.
Yeah. So it is only thing is that Dr. D.K. Swami has elaborated that what are the things to be taken forward with his direction and assistance as well as enthusiasm and interest. So we are always there from IIT Jammu, and we know that we are in some at some stage to have this software in our institute also. But it is not only the software. My request as well as my sharing with all who are participating in this group, with all experts and all attendees, is that in Delhi there are so many structures and so many buildings and strategic importance are there. So it will be fit to give one of these buildings with the assistance from or with our cooperation to have such kind of simulation exercise. And where we can give a free hand to Fluidyn and its group, where from IIT Jammu side will be joining, and from fire services, MHA, Dr. D.K. Swami, and also fire services here in Delhi, which we know very well, experts are there. Let us take one pilot study where, Mr. Tripathi and his team will be given the free hand to do this kind of simulation as a case study, which will really open up really lots of enthusiasm. Not that only CBRI is having our only research lab and Nagpur is developing, but we need to have some authentic as well as some pilot study here in Delhi. For that, whatever financial assistance is required or whatever facilitation is required, let us come forward for that.
Thank you, Dr. Ghosh. Thank you very much. I think a very good suggestion, and I'll try to take it up with the help of all of you.
I think someone from DMRC, Mr. Rajesh Jain, is there. It can be one of the buildings related to the metro stations. What do you think, Jain Saab? Are you there? I think Shamiji, you may have to take up that issue because
I'll take it up. I'll take the help of Dr. Chandan Ghosh, and thank you, Dr. Ghosh, for helping me out. Actually, I'm getting all the desired help from IIT Gandhinagar, from IIT Chennai, and now you are the another IIT who willingly, said that you are ready to help us out. So I hope. Dr. Ghosh, if you are only thinking to study that from the structural safety point of view, you have to go to the civil engineering department. If you want to do something from the fire perspective, I can assure that the director of Delhi Fire Service will help us out to identify the building, and you know, a lot of people, they are now they are coming forward to get it done. Probably we'll get some building also for this study work.
Are there any other questions, sir? Anyone else?
Hi, I am Atul Srivastava from Reliance.
Hello, Mr. Srivastava.
It is quite encouraging to see Fluidyn becoming more and more visible in recent times. You know, first I interacted with them a few years back at a conference in Delhi, and since then they are making themselves quite busy, which is quite visible, which is quite encouraging. Particularly in the 3D modeling, you know, not many players are there in the market. So as far as Reliance is concerned, we are looking for opportunities, particularly in oil and gas plants, where, you know, the location of FNG detectors is a challenge. You know, normally our design engineering consultants use the prescriptive methods to locate the FNG detectors, which is not always accurate. We have interacted on one-to-one basis with Fluidyn at Reliance also. And yes, we will try to engage whenever the economic conditions improve in our country and we get some projects. However, having said that, you know, we would like to engage them on some pilot projects so that they can prove their worth. You know, because always the project directors look for maximization of the utility with least of the cost involved, so they have to prove themselves whenever we engage them on a pilot basis, so that the project directors are quite impressed. Otherwise, if they spend time and money and the outputs are same as the prescriptive method, then probably it will have a setback. Thank you.
Thank you. Thank you, Srivastava. That's a very encouraging. Those are very encouraging words. We are always available. Don't worry about the cost element. We are more. We learn outside. Let's try to develop the technology and examples in India. Let's make it a showcase.
Thank you.
Anyone else, please? Anyone else would like to question or comment? Shamiji, I think we have to close it now. It's about 15 minutes in the time. So, Shamiji, okay,
I think we should thanks to all, and if you allow, I have also to go to attend one more meeting at 6. So,
Yeah.
so if there is nothing, then I think we can close this webinar today.
All right, sir. Thank you very much. Thank you, everyone. Again, we are organizing every 15 days. The focus is on the technology and development, and please join us. Bring us ideas. Give us ideas. Those are much more encouraging and important. We are trying to invite the students also to join in. We finance PhD and master programs, and I hope you'll join us in doing that. So these technologies can be developed in India instead of you're paying out a hefty sum to other countries and for the technology development there. Thank you again, everyone. Bye then, and have a nice day ahead. I hope COVID is not influencing much your decisions and orientations technologically. Thank you again. Bye then. I'll close the webinar.
Okay. Thanks everyone for the participant. Thanks.